Hey guys, welcome back to another video. Today I'll be talking about container security. This is a continuation of my Kubernetes security series, but this is more generic when it comes to working with containers and securing containers and the overall life cycle of a container and the potential vulnerabilities at each point in that life cycle. So let's jump into it. The first thing that we will point out is a high-level view of the container lifecycle when we are developing in a containerized environment. So when we develop our application, we will have a set of code. That code will be compiled. We will use a base image that is pre-existing and add the compiled executable to that base image to generate our application image. From there, our application image will be pushed to a container registry, and our Kubernetes cluster will pull from that container registry and deploy the container. At each of these steps, there are potential vulnerabilities, and in this video I will go through how we can combat those vulnerabilities, starting with the code. So let's have a look at some code security guidelines when it comes to containers. So first of all, we need to understand static and dynamic code analysis. Static code analysis is when we look at the code itself and glean information from the code based on simply how it's been written. Dynamic code analysis is when we execute the code and we glean some information from that based on different executions. So we can do things like unit tests to inspect the logic of the code, and we can also do performance tests, and these will both be dynamic code analysis. Whereas static code analysis, we can find security vulnerabilities, we can also find code smells, for example. We can look at the code coverage when it comes to unit tests and code duplications. All of these things will be covered under static code analysis, but in this video we're going to specifically look at vulnerabilities. And the output that you see on the right hand side is from a tool called SonarQube, and it is a very popular static code analysis tool that is used oftentimes in pipelines, continuous integration pipelines, in order to verify the quality of new code as it is added to our code base. So what does SonarQube do with regards to checking the security of our code and finding vulnerabilities? The first thing that it does is it checks for security injection rules. So these are things like SQL injection, cross-site scripting, or code injection. Any of these vulnerabilities may become present in our code inadvertently when we are developing, and SonarQube scans the code and finds these vulnerabilities. Another method that it uses is security configuration rules, and these are things like outdated or broken cryptographic algorithms. So if we're using those in our code, SonarQube will identify them and give us a warning that we should remove them, update to a new cryptographic algorithm. The next thing that we need to look at with regards to our code, and the code that will then be added to our container, is dependency scanning. So dependency scanning ensures dependencies do not contain vulnerabilities. There are a number of tools that we can use to do this, and generally what they will do is they will have a database of all the dependencies, all their versions, and some of those versions or dependencies will be flagged for security vulnerabilities that have been found. So when we scan our dependencies, the tool will cross-reference the database that they have available with the dependencies and the versions that we are using, and it will give us a warning if one of those dependencies or many of those dependencies have been found to be insecure. Some of the examples of tools that do dependency scanning are GitLab, Maven, and NPM. This is dependent obviously on the technologies that we're using. Maven and NPM are package managers for Java and JavaScript. So if we're working those languages, then we may use their dependency scanners. And GitLab is a software development platform that has an array of functionality. For example, we store our source code in GitLab. We can also run pipelines with GitLab, and GitLab obviously has a number of different specific functions, including dependency scanning as one of them. Next, let's look at image security. So when we are creating an image, there are a number of security best practices and guidelines that we need to follow. And some of these, for example, we should use base images that are up to date and trusted. As I said in the first slide, whenever we develop a container or a container image for our application, we'll generally be using a base image from an outside source. It could be a Ubuntu image, it could be an Alpine image, but we just have to make sure that when we are using that doesn't have any vulnerabilities itself, and it is what it says it is. So a lot of time with security, what we have to actually do is verify that the endpoint we're talking to is who we think it is, or the resource we're using is what we think it is. And that's what I mean by ensuring that it's trusted. Furthermore, when we're talking about keeping images up to date, images will generally be updated to a new version when security vulnerabilities are found, and those updated versions will obviously have fixes to those security vulnerabilities. So we don't want to use very old versions of the base images that we're using to build our application. Images should also be scanned, and a tool like Docker Bench can be used in this case, and this will essentially run through a large array of checks for similar best practices to what we're talking about here, and it will tell you if the image passes a check or fails a check, and you can update the image as necessary based on that output. So a very useful tool in your deployment pipeline. You should also run the image as non-root, because if you run the image as root, there is a greater chance that an attacker that gets to the container image itself will then be able to break out of the image and start to do things on the underlying host, and that will obviously increase the blast radius of any kind of security attack by a great deal. It's not as big of a deal if one container in an application gets attacked as it is if an entire node is attacked, and if we lose an entire node, then multiple applications could be affected, many containers could be affected. So that is a much more serious issue. We want to limit the privileges that the container itself has. Next, secrets should never be baked into an image. So when we are using, usernames and passwords, API keys, anything like this, service accounts, we want to mount those to the container. We don't want to have those sitting in a file somewhere in the container file system. Next, we want to minimize the packages in the image. And the way that we can think about this is we could potentially include the packages in our Docker file, include the code within our Docker file, and then compile the packages or the dependencies with the code and create the executable, and then run the executable at the end of our Docker file. However, that is not a best practice. It's better for us to first compile the executable, add the executable to the image, and then just run the executable. Next, we also want to minimize the open ports. We should only open ports that are absolutely necessary, because every time a port is open, that's another method that an attacker can gain access to our container. We can also do Docker file linting. Linting is another type of static analysis. In this case, however, we are statically analyzing the Docker file itself rather than the code. One example of a tool that can be used there is HadoLint. And finally, we can utilize security context within Kubernetes to modify how the container is run. An example is shown under here. In this case, we're running as user 1000, and we have added the capability to kill processes within the container. This is something that I will cover in more detail in a future video. I wanted to keep this one a little bit more generic to containers rather than going into the specifics of Kubernetes, but you will see that video very soon. And the final potential vulnerability is the registry itself, where all of the containers are stored. First of all, images should be signed and the signatures should be verified when we pull the images. So again, we need to make sure the image that we are pulling from the registry is what we expect it to be. One tool that we can use here is Docker Notary, and we can verify the signatures using an admission controller. The container registry should have limited access as well. So obviously the Kubernetes API will have to have access to the registry. Certain administrators may need access to the registry. The pipeline that we are using to push the containers to the registry will need to have some sort of authentication there so that it can send the images to the registry. But aside from that, we don't want to have our registry completely open for anyone to access our images. We want to lock that down as much as possible too. And to provide access to the Kubernetes API in terms of accessing the container registry, we can run this command here. So Kubernetes actually has a specific type of secret called Docker registry. And when we create this, it allows Kubernetes to then authenticate against the registry that we're using and pull down the images so that those images can be deployed to the cluster. So that is my video on container security. I really hope that was useful. If you have any questions, please do leave a comment and I will get back to you. Please like and subscribe, and I will talk to you in the next video.